After organomagnesium compound, we are going to discuss organolithium compound. Here we are going to discuss only one compound, that is alkyl lithium. You see here, it is quite similar to the organomagnesium compound, particularly with Grignard reagent. Here also this R is negative. If you see here, this is organometallic compound because there is a bond between carbon and metal. Here R is always negative and lithium is positive. So this R is carbanion. So you discuss this first. Now first of all we'll see how to prepare alkyl lithium. It is very simple. You take alkyl halide and add lithium. You will get alkyl lithium, and this is byproduct. So here I have given one example. If you take methyl bromide and you add lithium, you get methyl lithium and LiBr, lithium bromide. So this methyl lithium is actually having structure like this. This is the methyl lithium. You can see here, this is carbanion. So this is carbanion. So you are actually preparing carbanion. Now this carbanion can act as a base as well as a nucleophile. So this side of the board I am discussing all the reactions where this carbanion is acting as a nucleophile. Nucleophile means it is reacting with other carbon. It is forming carbon-carbon bond, and when this is acting as a base, this is forming bond with the hydrogen. Now see, this is strong base. This carbanion is a strong base. If one weak acid is present, then it is actually abstracting that proton. For example, we take here water. You know the pK value of water is around 16, which is very weak acid. But in presence of water, this carbanion is strong base and abstracting this proton and producing this lithium hydroxide. So this is methane is produced. So not only this one, any alkyl lithium is there, and if you find water, take out that proton, take out that acidic proton. Although it is weak acidic, but our methyl is now taking that alkyl group is a strong base and taking away that proton. So this acid base reaction. Even in presence of carboxylic acid, which is stronger acid as compared to this one, now it is taking that proton, and we get this salt. Now you can see here, even weak acid I am using this acetylene or any alkyl. You can see here terminal alkynes. So this proton is acidic because of sp hybridization of this carbon. So this is actually removing that proton and producing this kind of acetylide. So this acetylide you can utilize for further reactions, for other reactions to prepare non-terminal alkyne. But you remember, if any acidic proton is present in the reaction or even with the molecule, then definitely our carbanion is abstracting that proton. Instead of acting as a base, instead of acting as a nucleophile, it will act as a base. So actually this is the limitation of this organolithium compound. We cannot work with the compound where the acidic proton is present, because it will not act as a nucleophile in that case. Now see here, what if it is acting as a nucleophile? So it will form bond with the carbon. Now first of all, very similar reaction we discuss with Grignard reagent. Now this R is negative, and obviously this carbonyl carbon is positive. So R is going to join there, and this bond will open here, and Li will join there. So I have shown here the addition product. Now when we hydrolyze in presence of dilute acid, so you have to just replace Li with hydrogen. So you are going to prepare alcohol. In fact, you can prepare primary alcohol, secondary alcohol, tertiary alcohol, just like Grignard reagent. So I have not given here this reaction in more detail, which we discussed already with the Grignard reagent. So you remember, you can prepare primary, secondary and tertiary alcohol. It's only you have to change the aldehyde. You can start with formaldehyde to prepare primary alcohol, and you can go ahead. With ketone, it will form tertiary alcohol. So in this way, you can prepare primary, secondary and tertiary alcohol this is very useful reaction. Now see, when this is treated with epoxide, ethylene oxide, this bond is a polar bond, so these carbons are having positive charge. So are we always forming bond with the positively charged carbon? So you have to open this bond here on the oxygen and you have to join Li there. So you get here intermediate compound, this lithium oxide, alkoxide, and when we hydrolyze this, you can produce here a primary alcohol. So you can produce primary alcohol. So this alcohol can be prepared if here we replace here this hydrogen with another alkyl group, you can produce the secondary and even tertiary alcohol. So that is another thing. But again one more thing which we have to discuss here, that what will happen with the cyanide with nitrile compound. So this carbon is negative, so this carbon is positive, so R is going to join here again to the positively charged carbon. You have to open this bond on the nitrogen and join their lithium to get this intermediate addition compound. Now see, when we hydrolyze this, you have to break this bond, and you can see here from the water you have to join oxygen to this carbon, so you will get here ketone. So cyanide is converted to the ketone, and these are the side products. So you, in this way, you can convert cyanide into ketone by just doing this two-step reaction. Now what will happen when this is treated with a solid carbon dioxide? What will happen? So this is reacting to the carbon as usual. You have to open either this bond or this bond. They are identical. So if you open this bond here, then you have to join lithium to this oxygen and R to this carbon. So you get here this salt of carboxylic acid, and when we hydrolyze this, it is converted to the carboxylic acid. So again, when this is treated with alkyl halide, you have to join R to this and you have to remove X. So you get here higher alkane. So you can prepare higher alkane. Again, very important reaction. So in this way, in all these reactions, these alkyl group of the lithium, organolithium compound, or this alkyl lithium, is acting as a nucleophile, but in presence of slightly acidic proton, it will abstract that proton instead of going for all these reaction, and we get another product. So very simple product. We'll get here alkane, and probably these are not synthetically more important. So this is the drawback of organolithium compound. If there is acidic proton, you cannot use this compound. Thank you so much.